In this PowerPoint, we're going to talk about soil. So 4.2 is soil formation, and 4.3 is soil composition and properties. And so here are our learning objectives. Make sure you know what you need to know. And so soil is the upper layer of the Earth's crust. So basically it supports plants, animals, microbes, right? Basically, we wouldn't be here without soil because it grows our food and supports the animals that we eat and depend on. And so there are all kinds of things that help form soil. There's climate, topography, organisms, time. But first, we're going to talk about parent material. And so you need to know the basics of the rock cycle. All soil is coming from weathered rock, basically. And so igneous is from fire, usually from volcano, directly from the Earth's core, or sorry, not the core, the mantle, right? And so either it weathers and erodes into sediment to create sedimentary rock, or using a lot of heat and pressure, it ends up becoming metamorphic rock. And so it's a cycle. Really, all the other rocks can become the other types depending on their conditions. So here's another little infographic about the rock cycle. And another one about the rock cycle. Which one do you like? You can pick any of those, but basically you should know your 3 rocks. And then here are different types of rocks, right? You have igneous, like obsidian and granite. Also, right, basalt is actually an igneous rock, which the granite and basalt are the big crust rocks that we talk about. Metamorphic rocks and sedimentary rocks. And some more rocks. Okay, moving on. So from that rock, right, we call that parent material, and it's where soil is coming from. It's the nature of those rocks that the soil is coming from is really going to affect all the different properties of the soil. And, the rocks can be native, so the underlying bedrock and what that place is made of, but it could also be transported, whether it's by wind, water, glacier, and even, by humans. So obviously, weathering of parent material is going to take time. And so if you look at this picture, this diagram here, in the very far back, you have this immature soil with the bedrock and rock fragments, and the moss and the lichen are going to come in and, attach to those rocks and really start breaking them down. Then you have really young soil that can really only support certain things. And then as those organics are starting to get mixed into the soil, you end up with a more mature soil profile. And so depending on what factors are there in the earth with the soil, that may preserve that profile or it may erode that profile. So, at some point, soil is going to reach an equilibrium. Another factor is climate. And so just like climate, right, temperature and precipitation, they're going to affect the weathering process. Looking at the conditions for soil organisms, so there's tons and tons of organisms in the soil, lots of microbes. What plants are going to grow there, how fast the decomposition rates are, what the soil pH is going to be, and then also any chemical reactions happening in the soil are going to be affected by temperature and water. And that's why our biomes all have different soil horizons, because the soil will actually form faster with high temperatures and lots of rainfall. So, you're going to end up with a lot of, a lot faster soil formation with these conditions. Depending on the topography, your soil is going to form in different ways. So there could be, slope or elevation, high or low, is it exposed to wind or not? So that is all going to affect how fast your soil is going to form. And then, of course, weathering is almost probably the most important part of soil formation. You have physical weathering, so with temperature changes, freezing, thawing, plant roots are actually going to crack rock open. You have burrowing animals that are going to affect the rocks. And then also there's chemical weathering. So water is the catalyst for that. You end up with a lot of different types of chemical reactions in the presence of water.
And water not only makes soil, but it can erode it or take it away from where it is, and through soil erosion. So physical removal of soil by wind and or water. So basically the wind or water is picking up those soil particles and moving them. It's a natural process. It happens with or without humans. And it's actually really important because it allows for the deposition of sediment downstream or downwind of wherever the soil was picked up. And so then it gets put down. And that those soil particles are really important, is a really important mechanism of nutrients to a system. However, through anthropogenic practices, erosion is increased. And so we're going to talk about it more in Unit 5 when we get to agriculture, or land use in general, actually. But agricultural practices increases erosion a lot, whether it's through tilling the soil or removing vegetation, such as deforestation, but also other kinds of removal of vegetation. If the roots aren't in place, then the roots aren't there to actually hold the soil in place. And so when the soil is looser, it's easier to erode. Also, impervious surface causes more surface runoff, and so the water is just moving a lot faster down that surface as opposed to a surface that's not impervious, where it could actually infiltrate and percolate down into the ground. And so as the water is running across the surface, it's pulling that soil along with it. And then climate change is a huge reason for soil erosion, mostly because of drought, and dry soil erodes very, very easily. So ecosystem services of water filtration happens with soil, and soil is very effective at cleaning and filtering water, because sediments can actually hold on to pollutants. Those pollutants can actually bind to the sediment. Again, we'll talk about it more in future units. But by holding on to those pollutants, sediments actually allow clean water through and holding back the pollutants. And not only that, the organisms that are in the soil naturally can help break down pollutants, thus allowing for water to go through clean. And so that's why you wouldn't want to drink water from like a reservoir or a lake or stream, because it's just sitting there, really. Whereas if you drink groundwater from like well water, you can actually drink water straight out of the ground because the soil is actually cleaning the water. And so if we protect our soils, we can actually protect our water quality. And remember that water quality is huge, right? Babies are dying, and we flush our toilets with drinkable water. I had to say it. Anyway, soil conservation is key. And so we will talk more about soil conservation methods when we get to Unit 5 and land use.
So soil is composed of minerals, organics, and water and air, basically. The majority of it is mineral material, but then a lot of it is water and air, so those spaces in between the particles. So 50% is really an average of these air spaces, well, air and water, right, pore spaces. So depending on pore space, right, whether it's less or more, we can talk about its porosity. So how if it has a high porosity, it has lots of air, lots of space, and if it's low porosity, it would have little air spaces. But these spaces are allowing water and air to really travel through the soil. And why do we even care about air in the soil? Well, plant roots that are in the soil actually need air. And depending on how many pores you have, it can increase its water holding capacity. So looking at water holding capacity, certain types of soil can hold on to more water than others. So for example, if I look on the left there is really representative of sand. You have these large pore spaces, but there are not a lot of them. And so the water will actually flow through it very, very high, or will have a high permeability or a low water holding capacity. Whereas on the right there is more representative of something like clay, and the water will not actually run through because the pore spaces are so small and there are so many of them that the water will actually kind of get caught up in between the soil particles. And so if you have small pore spaces and lots of them, you have low permeability or a high water holding capacity. And so I was just talking about sand and clay, and so here we are, right? Sand, when we look at soil, really there are just three sizes of particle that we can really concern ourselves with. There's sand, silt, and clay. And so sand is our largest, clay being the lowest. And so the larger the particle, the lower the water holding capacity and the higher permeability that soil will have. And on the opposite end, right, we have the smaller the particle, the higher the water holding capacity and the lower permeability it has. And so looking at these three different particles of soil or size particles of soil, we can determine what texture the soil is, because soil textures are a combination of those three different size particles. And so here we have a soil triangle. We will have or will go over it in class depending on when we watch this video. But basically, we look at the percent sand, the percent silt, and the percent clay. Follow the graph, and where the lines intersect will give you the definition of your soil. Here is a closer look at the soil texture triangle or soil triangle. And in this particular picture, the numbers are not written in the direction that you would read it, but I will try and make sure to do so when I give these to you. Really pay attention to the examples that I'm giving you in class to review. It's kind of hard to explain on a PowerPoint, but basically, let's say, for example, right, if I have, I don't know, 40% silt, so you can see on the right hand of the triangle, you have silt on the side. So I'm going to come down 40% silt, 40% sand, and 20% clay. You can see the white arrows pointing to an intersection of loam. So loam is the kind of soil that is a combination of silt, sand, and clay. If you have questions with the soil triangle, please make sure that you come in and clarify with me in person. So the kind of soil texture that a soil has will affect the properties that it has. So something that's really sandy is going to have a low water holding capacity, and it's just not going to hold on to water, whereas something high in clay is actually going to hold on to water almost too well. It is really poor drainage and not a lot of airspace, so oxygen will be low. And then also, clay is negatively charged, so it actually holds on to plant nutrients, where sandy soils really don't hold on to nutrients very well. And so, if we're depending on what we're using a soil for, right, that agricultural soil is the best one is loam because it has kind of a mixture of all the kinds of properties. It holds on to water, but not too much, like I said. It holds on to nutrients, but not too much, like I said, lots of aeration, etc., etc. All right, so let's look a little closely at clay. So clay has negative charge, and so these nutrients are actually going to absorb onto the clay particle a lot better than other soil particles. So just a little picture of what I was talking about before. Yet another sweet little picture of a clay particle negatively charged, attracting those positively charged soil nutrients. And so when we're talking about soil, we may kind of throw some words out there. So infiltration is the downward movement of water through the soil. So as water is infiltrating, you can also kind of think of it right as permeability. So like you have like a high infiltration rate if you have high permeability where water is really going through it fast. Leaching is where minerals and organic matter get brought down into lower layers, so they're actually moving with the water usually. And like I said before, depending on the type of soil, will determine how fast water infiltrates and how fast nutrients are leaching. Soil pH is another property. Uh, most soils are in the pH range of 4 to 8. There are other ones that are super acidic or very, very basic, but in general, soils are in this 4 to 8 range. And I'm sure that you know what pH is, but just in case you don't, pH is a measure of how many hydrogen ions you actually have in solution. And so pH affects the availability of plant nutrients. So if the soil is too acidic or too basic, compounds aren't going to dissolve because that positively charged hydrogen ion is going to affect the other ions around it. So if it's too acidic, you can actually mitigate that by adding limestone to try and buffer out the acid. If it's too basic, then organic compounds can help you solve that problem. And so depending on what your pH is, your nutrients are going to be available. So you can see at a neutral pH of 7, most nutrients are available, but if I get too acid or too basic on either end of the pH scale, then my availability of nutrients is actually going to decrease. So that's why it's so important for your soil pH to be spot on. So what nutrients are we most concerned with? Well, our macronutrients are our big ones. We have NPK, so nitrogen, phosphorus, potassium. If you look on any fertilizer bag or whatever it is, whether it's organic or inorganic, doesn't really matter. You have an NPK number. So what are the ratios of nitrogen to phosphorus to potassium? But plants obviously need a lot more than just those three. So they do need micronutrients. So just in smaller, smaller amounts and smaller atomic structure. So as soil's forming in a specific area, It has different components. And if I were to dig down into the earth and look at a cross section of my hole, right, like the wall of my hole, you would see different strata or layers. And so from the top down, you have your organic material at the top, so your O layer, and then an A, B, C. Sometimes they throw an E in there also. You can really lump A and E together, but depending on where you're looking. But your A horizon is really your topsoil. It's like this accumulation of organic matter and a little bit of a little more mineral material. Sorry. Your B horizon actually is where your nutrients leach down into. So a lot of roots are down in the B horizon. And then C is really just weathered plant material, not too much organic matter. And finally, you have that bedrock or parent material that we had talked about before. So the O layer, like I said, is the uppermost layer. It's super rich in organic material. We call the organic material in soil humus, Humus, not hummus. It's not a delicious chickpea spread, but it's a nice, dark, rich organic matter. And so plant litter is accumulating on the top of the surface and then decaying, and that's where we get it from. So in the desert, there's no organic horizon, but in other places, you have a fairly large organic layer. So, who knows? Topsoil is in horizon A is very dark and rich. So, like I said, it's organic matter, but it also has particles of parent material in there, and so it's very nutrient poor because rain will infiltrate down and leach out the nutrients in that A layer, accumulating in the B layer. Here you have your B layer. It is underneath the A layer, and this is where the minerals from that A layer go down into, and it's usually really rich in iron and clay, and the clay, remember, hangs on to those nutrients. We have our C horizon, and so you have these weathered pieces of rock and unweathered parent material. Most roots don't go down this deep, and usually this is where it's saturated with groundwater. So when your pore spaces are completely full of water, this is what we call groundwater. So there isn't just dead decaying matter and mineral material, right? You also have organisms that live in the soil. And so you have tons of bacteria and worms and all kinds of things that are in there, ants. And so all of these have functions within the soil and are living in that ecosystem. The worms are digesting materials to help turn over decaying matter and also aerate the soil with their tunnels, as do ants. So, they do have purpose in the soil for many reasons. A really important soil organism is mycorrhizae, and this is a fungus on the roots of some plants that help absorb essential nutrients from the soil. And basically, these mycorrhizae are connected and to all plants in a certain area. It's pretty awesome. And the mycelium are these thread-like parts of the fungus that are extending beyond the roots. So it's like on the roots and then beyond to try and absorb all this nutrients like beyond the actual roots. So that is super cool. So soil organisms in general provide so many ecosystem services. They're so important. They decay and cycle organic matter, prevent soil erosion, break down toxic materials, clean water, and aerate the soil. And so the soil actually is a really important part of our environment, and thus concludes our PowerPoint on it.